111. 111. I'm amazed. I'm overwhelmed. I'm stunned. 111 is the number of registered participants for this evening, and this does not even include 10 persons who could not be here this evening because they were ill and had to cancel in the last few hours. When we started organizing this Zephyr project meetup, we sat together and said, how many people will come? Will it be a fail, maybe with 15, 20 people, just the organizers? Will it be a success with 70, 80 people? And now there are 111 people here. I'm amazed. So it's great that you all decided to join us here for an exciting evening with some great talks, with some food, and talking about Zephyr this evening. So welcome here on behalf of Noser Engineering. Michael Eisenring will be hosting this evening together with me. I will start. Michael will take over later on for the host of this evening. And ZHW, Institute of Embedded Systems, that I'm heading here, together with Noser Engineering, we are organizing this evening. A few organizational issues. If you require Wi-Fi, there are codes on the posters on the side. We will be recording the sessions and we'll promote these after the talks or after the evening through the Linux Foundation, Zephyr project. And one more thing, emergency exits to your right and to your left. On the right side, it's on the right side here, and then to the right, you're outside of the building. Okay, let me kick off this evening with a few thoughts about Zephyr in research and education. How do we use it? Why do we use it? What are some issues or success points that we have using Zephyr in our environment? From our Institute of Embedded Systems, we basically, all our systems circle around embedded processing and communication. And then on the left side, we have many topics arranged around that, around these embedded processing and communication. And we have industrial partners, we have students that come to us, especially for vendor-independent expertise on embedded systems. We do research on one side, concepts, proof of concepts, reference implementations, evaluations, studies on how something could be. So that's one part of our equation. And the other half of our things is education in bachelor, master's, and continuing education. Continuing education is after the master or after the bachelor, when you come back after some years of experience in the industry and come back for a very specific training on a special field. With the education, we of course we have lectures, we have lots of hands-on labs. We do have theses, so bachelor and masters. Right now, this week, we have 20 bachelor theses that start or have started this week for half a year. And we also have hands-on labs in the continuing education. So it's a broad spectrum of courses that we have there, and in some of the courses we do have Zephyr as a part of those courses. Okay, so when we work in different projects at the Institute of Embedded Systems, we provide the expertise of embedded systems, of communication. But in all our projects, there's a second part of expertise, and that expertise typically comes from the industrial partners or from other research entities. So how do you build smart buildings? How do you do precision agriculture? How do you use these things in healthcare? So there's always an application field, an application expertise that has to come to the equation, and adding the two things together sets up an interesting system and a successful system. And so a lot of these systems, not all of them, but quite a lot of those systems are microcontroller based. Of course, we have also others that are GPU based or FPGA based, larger processor based, but quite a few of the systems are microcontroller based. And when you have the application field on one side, the embedded thing on the other side, and you combine these things, you find yourself, oh, I used this processor before. Oh, I've used this hardware device before. I've used this before. And you combine these things in new ways. And so we had a question a few years ago and said, how about having a universal build system to set up such projects, to be individual variations, to start projects, to make proof of concepts in a rapid way. And we are combining there things like microcontrollers from different vendors, with different power down modes, with different peripherals, with different cores. And we have another box of components like services like the RTOS services, threading, messaging, queuing, synchronization, but also secure boot, secure storage, file system logging. So that's a second part of building components that we want to put there. And then we have a huge field of external chips, sensors, secure elements, special memories, RTCs, and also external chips, communication interfaces, wired and wireless. And there are lots of different wireless components there, from LoRaWAN, RFC, Bluetooth Low Energy, IEEE 802.15.4. And the last part that we have are communication stacks and libraries to process things. So we're putting this together in a lot of variations, always very application dependent, and we don't want to start each time from scratch. So the plan was, can we find such a universal system? And then and then the question is, well, can Zephyr be this Swiss Army knife of embedded microcontroller systems? And if we would use Zephyr, would this work out for a lot of projects and give us some momentum there and enable us to reuse things? Or would it just be a lot of overhead, a lot of problems that you have to go through, a lot of framework introduction that we do? And would not pay off. So that was the question when one of our master students here, Benjamin Herring, who's in the room, I think he didn't wanted me to mention him. Benjamin, where are you? Over there. So 2019, Benjamin wrote his master thesis, and the title was Consolidating IoT Firmware Architectures with Zephyr. At that time, version 1.14 of Zephyr. And Benjamin ported this to one of our low power, few centers on there. Martin Zimmermann as a customer is also here. Maybe you remember the node there. We did quite a lot of experiments with that, and Benjamin ported Zephyr to that hardware and experimented with demo boards of various vendors as well there. And at that time, in the Institute and outside the Institute, quite a few people asked us, well, Benjamin and Andreas, are you serious about Zephyr here? Isn't that just another RTOS? Isn't that just something, well, just another trick of the day that we have here? It will fade away before the master thesis is over, right? But it has caught on, and we are using it in a lot of our research projects today. Just some examples here. This is an InnoSwiss project we are just finishing for a startup called Amphora. Olive oil as a service, if you want, where you have an intelligent tab with NFC to identify the container, with sensors to have fill level and quality measurements on there. You see the print here, and putting it all together, sending the things away over LoRaWAN. Some of the components there are very off the shelf, some are pretty new, but putting this all together, Zephyr enabled us to do this quite quickly. Or another example here from another group for dependable, power-efficient AI on highly constrained systems. So to demonstrate software AI orchestration on different platforms, and if you go to low power, highly constrained platforms, microcontrollers, you can do this on a moon landing program here as a demonstration for an industrial customer here on a dual core Nordic processing board here. So these are just two of the examples where we use it. We have a booth outside where we have 7 different projects on display running on completely different architectures. You see some of them named here. So while having some food and drinks afterwards, go by and have a look at some of the projects we're using there, or where we're using Zephyr for these projects. So that is the research part. Now the education part. How do we use this in teaching? Advanced bachelor course, Microcomputer Systems 1, in a full-time study. This is 5th semester for IT students, for electrical engineering students, and system engineers. And there we started 3 years ago introducing Zephyr. We are currently on Zephyr 4.2. The course just finished before Christmas. And we did, with Zephyr 4.2, threads, inter-thread communication, Z-test, we did secure boot, and every year we are extending that Zephyr part on there. We have our own board, introduced this last summer, STM32H5 based, with a display, and where we do the threading on this, and we also use this in other courses there. Now, one important point when we talk about Zephyr in education is we do not want to teach Zephyr in education. Zephyr is just the platform we use to be able to teach embedded systems and embedded systems techniques in there. So we want to enable fast learning progress, and that's why we are using Zephyr in there. Here is an example of a master course, Dining Philosophers problem on the STM board that you can run there, analyzing the different threads in there. And enabling fast learning progress, when you introduce it to the classroom, the students bring their own devices, their own host devices, their laptops. And they have Mac OS, they have Windows, they have ARM processors, other Intel processors, AMD. So it's totally different for every student what they have. And still we need a development environment that works, reproducible, in a uniform way that's easy to maintain, and we do not want to spend 2 weeks setting up the tool chain in there. So first we experimented with virtual machines. Was not really a success. It took a long time to install this. It didn't have enough memories on the computer, not enough disk space, whatever. And we came up with a container-based solution. We have published that on that, about it, and you can install this on a virtualization environment on Mac OS or Linux, or on WSL2 for Windows. And this runs smoothly within a short time. You can set up your bring up your server on any of the computer systems of the students. And we're also using this in continuing education. My colleague Simon Künzli has a course on security and embedded systems. He teaches this here in school, but he also teaches this for quite a few companies, where he goes to the companies and teaches this. And there's hands-on labs in there, working with the STM secure element, among others, here, showing how you could use this to fulfill your CRA requirements in there. Okay, so over those last 7 years, we have used Zephyr in research for numerous projects, for many MCUs from different vendors, for countless devices, lots of communication interfaces, protocol stacks, and we have, like at the Institute, like a community of engineers who work with Zephyr and who support each other, support customers with Zephyr, and also develop the education modules there, where we use Zephyr as a platform to teach embedded systems and to enable a fast learning progress. In student thesis, Zephyr allows us to have the students start very quickly on their projects, so they don't have to start from scratch. We can support them well there to put together systems within those couple of weeks that they have to get such a system up and running. And in continuous education, we have it to have hands-on labs in the different courses, and gives us a good tool to bring hands-on training to those lectures. So, 7 years ago, the question was, Benjamin, Andreas, are you serious about Zephyr? And tonight, 111 people registered here, 10 more who would have wanted to come but were ill, and 111, I'm amazed, I'm overwhelmed, I'm stunned. Great that you all are here, and I'm very much looking forward to all great talks that we will have. And with that, I would like to hand over to Michael for the hosting of the evening and to the talks there. Michael,
Thank you very much.
Take over.